Alright, we're now in lesson 6, solving two-step equations. Alright, so let's go back from lesson 5. Lesson 5 talked about undoing things, okay? And which meant that we needed to do inverse operations. So that meant that whatever operation you saw in the equation, you want to do the opposite, the inverse operation. So if you saw an addition, then you want to do a subtraction. If you see a subtraction, you want to do an addition, and if you see a multiplication, you want to do division. If you see a division, you want to do a multiplication. Alright, so to solve equations with two or more steps, apply the inverse operations in reverse order. Let me explain how this works. You guys you know how a car is built. So a car is built in small parts and gets added on and gets added on and gets added on. And eventually at the end you have a final product of a car. So what you want to do is take away the car in parts. So how is that done? So we have to go backwards, and so you must do the opposite, okay, the opposite of everything that you did. So instead of putting things together, you're taking away things together, taking things away, and you're going in a reverse order, opposite order. So we're going to do the same thing with solving two-step equation. You'll see what I'm talking about as you can see how I apply these reverse inverse operations. Okay, so what we're going to do is we're going to use the same idea that I talked about earlier about building a car and then working backwards on taking the car apart. So the car is at the end product. What's our end product in the equation? Our end product is 19. So how do we get 19? Well, we have an unknown variable x, and then we divide it by 2, then add a 3, and our product would be 19. So that's the same way you want to look at it, but we'll be going backwards. So our first step was we're going to take our x and divide it by 2. So here, our operation performed on x is to divide by 2. So this would be our first step. Then our next step was to add 3, so this would be our second step. So we're looking at it going this way. Okay, first step, divide by 2, second step, add by 3. Now, to solve for x, we're gonna now work backwards. We're gonna go this way. So we're gonna work backwards, going up, and so our operation is to isolate x. So what we're gonna do is we're gonna work backwards, so we're gonna start from the bottom here, and then move ourselves up. So our first step is not to add 3, but we're going to do the inverse. So we take our operation, do the inverse. So instead of adding 3, we're going to subtract 3. And then our second step would be, instead of dividing by 2, would be to multiply by 2. So if we were to solve and find out how we get 19, our first step was to divide by 2. And when we go backwards, this first step would be our last step with the reverse value, which would be multiplied by 2. So let's go ahead and go through this. So our first step to solve for x is to subtract by 3, which is step 1 here. So we're going to go ahead and subtract 3. The 3's are going to cancel. And I have x over 2 is going to equal 16. And again, we can draw a line through the middle. Now our next step is to multiply by 2. That would be step 2 to solve for x. So I'm going to go ahead and multiply by 2. The 2's are going to cancel. And so x equals 16 times 2. So x is going to equal to 32. Again, when you have solved your answer, check it by plugging it back into the equation. So now I'm taking my answer, plugging it in, and I'm not doing this operation. I would take my 32 and divide it by 2, and then add a 3, and it should equal the product of 19. Now, for the second example, I got 3.2 plus x over 2.5 equals 4.6. Our end product is 4.6. So to get this end product, our first step was to take our unknown variable of x and divide it by 2.5. So that's the first step right here. Our second step is to add 3.2. So this would be our second step. Now, working backwards, now we're going to go this way, going up. So this would be our first step. But again, we gotta, instead of adding 3.2, we're gonna subtract 3.2 because we're doing the inverse operation. And then step 2 would be, instead of dividing by 2.5, would be to multiply by 2.5. So the first thing is to subtract 3.2. So I'm gonna go ahead and subtract 3.2 on both sides. And these are gonna cancel. And so x divided by 2.5, and I'll draw a line right here to keep everything straight. 4.6 minus 3.2, and you can do this in the calculator, but this is going to equal 1.4. Now the second operation here to isolate to solve for x is to multiply by 2.5. So we're going to multiply 2.5 and multiply this by 2.5. These are going to cancel. And we have x going to equal to 1.4 times 2.5. You can do this in the calculator, and you're going to get a value of 3.5. And so this is what we're going to be doing for the next set of problems. I want you to look at it as the reversal of how to get that product, and then that's how you're able to get your steps. And you always do the inverse of the operation. Alright, we're going to go ahead and now do a shorthand version of how we did the tables to kind of show the operations. So in order for us to get 2, we take f and then we add 2.5. So here I'm going to just say add 2.5. If I add 2.5, then divide by 3, so I divide by 3, that would give us our product of 2. So now I'm going to work backwards, okay? But then again, do the inverse operation. So we want to in order for us to solve for f, we want to do not divide by 3, but we want to multiply by 3. So we're going to multiply by 3. So that would get rid of this 3. And then instead of adding 2.5, our final operation should be the opposite of adding 2.5, which is to subtract 2.5. So we're going to go ahead and do the following operations. We're going to do f plus 2.5 divided by 3. This equals to 2. And what we're going to do is we're going to first multiply by 3. That would be our first operation, so we're going to go ahead and do that. Multiply this side by 3. Here you can put it like that as a parentheses. And then multiply this side by 3. The 3 is going to cancel. And now we have f equals, or f plus 2.5 is going to equal 2 times 3, which is 6. Our next operation would be to subtract 2.5. If I subtract 2.5, I will isolate and have f by itself. So I'll go ahead and subtract 2.5. That will cancel, and I have f equal to 6 minus 2.5. 6 minus 2.5 will give us 3.5. And that would be our answer. And you can verify this, plug it back into the equation, and then make sure that it equals to 2. Alright, for the second example, we have x minus 1 divided by 7 equals 1. So the operation, if I were to solve for 1, I would have to subtract 1 first, then divide by 7. So the opposite would be to multiply by 7 and add a 1. Okay, so that's what I would do. So I'm going to go ahead and copy this here. X minus 1 over 7 equals 1. Okay, I'll draw a straight line, that way you guys can see. So first thing is to multiply both sides by 7. Makes sense because if we want to solve for x, we need to get rid of this division of 7. So we want to multiply both sides by 7. So multiply this side by 7, this side by 7. Let's get rid of that 7. Next thing is we want to then, well, let's rewrite it. We got x minus 1 is going to equal to 1 times 7 is 7. And then we can go ahead and do the operation of adding a 1, okay? Because we already multiplied by 7, let's go ahead and add a 1. So we're going to go ahead and add a 1. These will cancel. And I have x equal to 8. And there's our answer. Again, you can go ahead and verify, plug it in, find out if it equals 1. All right, the final one, 16r minus 12 equals 4. So how do I find r? So I would need to multiply 16. So I write down, I'll multiply by 16. And then I would subtract 12 to get the value of negative 4. So how do I find negative 4? We take our r, multiply by 16, then subtract a 12. So subtract a 12. So that means we're going to add a 12. And then we're going to not multiply by 16, but we're going to divide by 16. So that would be our operation. So we're always thinking opposite inverse operation. So first thing is to add a 12. So we're going to go ahead and add a 12. These are going to cancel. The 12s are going to cancel. And we have 16r equals to 12 minus 4 is going to be 8. And the last operation is to divide by 16. So we're going to go ahead and divide both sides by 16. 16s on this side are going to cancel, and I have r isolated. R is going to equal to 8 divided by 16, or in this case it's going to equal to 1/2, and that would be our answer. And again, you can go back, plug it in, verify that it equals to negative 4 back into the equation. All right. Now we're going to do equations by using or by doing combined like terms. So these equations get a little bit longer, but they can be simplified, so then you can do these two-step operations. So for the first one, we have 2x minus 14 plus 4. Well, what things can we combine? Well, what we can combine is going to be the 14, the minus 14, and the 4. So we can combine those two into one number. So this can become then 2x minus 14 plus 4. Again, you're going to subtract 14 and add 4. You owe somebody $14 and you have $4, so that means that you're still minus $10. So it's going to be minus 14 plus 4 is minus 10, and that's going to equal to 10. All right, so now we have this, and now we're going to be in a two-step equation. So if we want to look at this, the first step, okay, if you haven't noticed this, the first thing is to multiply by 2 and then subtract 10. So that means our first step should be the last step, which is to, instead of subtract 10, we're going to go ahead and add 10. So I'm just going to now talk about it instead of writing everything down. So my last step was to subtract 10 to get 10. So then I'm going to add 10 on both sides. Okay, that's going to cancel. And so what you have here is 2x is going to equal 10 plus 10 is 10. Now, the first time we had to multiply the x by 2, so that means we're going to do the opposite. We're going to divide by 2. So we're going to go ahead and divide by 2. Those are going to cancel, and x equals to 5. Okay, so that would be our final answer. And if you wanted to know what were my steps from the beginning, okay, so this was here I needed to multiply by 2, then subtract 10, so it was add 10, and then it would be divide by 2. Now let's look at this one right here. 2j minus 4j plus 10 equals 12. So what can we combine? We can combine the j's. So we're going to go ahead and combine the values of 2j minus 4j. 2j minus 4j is going to give us negative 2j. We bring down the 10, and that's going to give us 12. If I'm looking at the operation here, to solve, if I want to know how to get to 12, I would take my j and multiply by negative 2. So I would say multiply by negative 2, and then I would add a 10. So the opposite is to subtract 10 and divide by negative 2. So that would be our operation right here. So we're going to go ahead and subtract 10 on both sides. These will cancel, and you have negative 2j. It's going to equal to 2. And then the last thing is to divide the negative 2 on both sides. These will cancel, and you have j equal to 2 divided by negative 2, which is a negative 1, and then that would be our answer. Okay, this is our last problem here. Let's try an application problem. Write an equation for the function described. The output of a function is 8 more than 3 times the input. Find the input when the output is negative 1. Okay, so the output is negative 1. So let's say this whole thing equals negative 1. So I'll just go ahead. This equals negative 1. Okay, the output of a function is, so all of this negative 1 is going to be equal to 8 more than 3 times the input. So we'll go ahead and change the input, and let's call that x. So 8 more than 3 times the input, so we're going to add 8 to the input, which is 3 times. So that means it's 3x. So 3 times the input of x, and then there's 8 more of those, and that'll equal the output, which is negative 1. So that would be our equation written down, okay, from verbal. All right, so if we were to solve this really quick, and I'll just write really quick here what would be our operation. So in order for me to get negative 1, I take x multiplied by 3, and then I would add 8. Opposite of that would be subtract 8 and then divide by 3. So this is the operation that we're going to go ahead and apply. So the first thing is to get rid of the 8, subtract by 8. So we're going to subtract 8 to isolate x. This will cancel, and you're left with 3x equal to, and again I can draw a straight line this way, 3x is going to equal to negative 1, negative 8. Again, when you combine them, this is going to equal to negative 9. And again, you owe somebody $1, then you owe somebody else $8 combined, you owe them $9, so you're negative $9. And the last step is to divide by 3. So we're going to go ahead and divide by 3 to isolate x. We're going to divide everything by 3, so these are going to cancel, and you have x equal to a negative divided by a positive. A negative divided by a positive is going to give you a negative, and 9 divides into 3 times, and then this would be our answer. So our answer would be negative 3. Again, you want to check it, so we'll just go ahead and do this on the side. So I'm going to go ahead and just over here, I'm going to go ahead and just check it. Alright, so I'm going to go ahead and take 3 and plug in a negative 3, and then we're going to add an 8, and does that equal negative 1? So 3 times negative 3 is a negative 9. If you add 8, okay, does that equal negative 1? Yes, it does. Negative 9 plus 8 is negative 1, and it does therefore equal negative 1. So that means that we did it correctly. Alright, so this is the last problem, and I guess we'll see you guys tomorrow, and that's it. Bye.